First, a disclaimer. This tutorial turned out far from great. Actually, it is advised not to watch it at all, instead searching for a better one elsewhere. But nevertheless, more for posterity and reference more than anything else, the tutorial will commence now. Welcome! This will be a brief tutorial showcasing how to synchronize the frame rate of time-lapse video footage with the pace of a piece of audio. In essence, we will synchronize the relationship between BPM and FPS, beats per minute and frames per second, the pace of the audio and the frame rate of the video. It is assumed that you already have FFmpeg installed, and we will be using a custom Grasshopper definition to easily find the correct values, within a tolerance of 1 deviated frame per second. With the final output frame rate of 60 FPS, such a tolerance might not be indiscernible, but it is practical for our use case. We will be using 2 video clips, so the first thing we'll do is merging these, and we have picked a piece of audio, which in terms of atmosphere might be an ill match, but which has a very clear beat, which is preferable for this tutorial use case. If you do not know the BPM for any song you want to use, this website, songbpm.com, utilizes song data provided by Spotify, so one might assume that the tempo here is stated to be correct. So to merge these 2 clips, we'll utilize Command Prompt and FFmpeg, so we can hold the Windows key and R for run, and then we can type and enter CMD. And then the first thing we should do, if the footage is stored on another drive than the user default drive, then we'll simply enter the drive letter followed by a colon and enter. And now we can change the directory to this directory. It's perhaps easiest to simply copy this, go back to the command prompt, change directory and Ctrl V and enter. Now we are here, very good. For FFmpeg to properly know which files are going to be merged, then we'll create a file list, so we'll do that. We can copy this here. This will create a text file with only the file names of this directory. And then we can open this here. It's important to remove the first line there. And then if you have a lot of these lines, in this case there's only 2, but we can do Ctrl F to find, and then we can find the underscore, and then we can find all, and then we can simply go back 1, and then let's type file and space. Very good. Now we can save this. This is how the file list should look. We can close this. And then to merge these 2 files with the help of this file list explicitly stating these 2 files, we can simply input this command here, make sure to properly reference your installation of FFmpeg, and then we'll go back to the command prompt and Ctrl V and enter. When you see the line with the directory as well as the blinking underscore, then the merge is complete. And here we have it. It is 1 file of a little under 17 minutes instead of these 2, which are the same. And it also has the same frame rate, and although we don't want the audio for this in the output, it is still retained as of now. Now let's go to Grasshopper and input all the correct values for this specific situation. So the BPM of this music is 130 BPM. The frame rate in FPS of the parent video, in this case, is the original one. And although this is stated a little abbreviated here as 23.98, if we open this in VLC and Ctrl I, then we can go to codec, and we see that the frame rate can be more accurately approximated to 23.978. And then in this particular use case, we want the frame per frame rate, the sort of visual frame rates, how frequently the images are updated, to be synchronized to every quarter note, so 4 for each measure. So we'll do 1 here, for 1 beat per frame change. We also want to use only the first 1 minute and 28 seconds of the song for this specific time lapse. And then the original duration of the video footage amounted to 16 minutes and 46 seconds. Having input these values, I think we are ready to progress. For the frame rate of the actual image change to be synchronized to every beat, 4 in each measure, the suitable frame rate is 2.167 FPS. This, however, is a very, very low frame rate in terms of actual playback. And to make playback less problematic, we'll use a fill-in frame rate, in effect duplicating the actual images a certain amount of times. And the fill-in frame rate It can be manually selected here from a list of suitable factors, all relating to the actual image per image frame rates. And then we can simply find here which deviation in frames that is the most suitable. Generally, as long as it's less than a frame, it's all good, but we can always strive for an as small amount as possible, while also taking into account the fact that the higher the frame rate, the larger the file size will be for the intermediary files. So here we can see here under index 3, index start as 0, so this is the fourth index, we see that the deviation is only 0.141 frames, and that is if we choose the multiple of 23.837. So we'll select this, index number 3, and here we have the fill-in frame rate stated. Very good. Verifying that we have input everything correctly for the purple parameters here, we can move forward to the extraction of frames. This utilizes the already calculated extraction frame rate stated here. So we can simply copy this, taking note that this should be run with PowerShell. We can copy this data only, and we can go back to our directory, and then we can hold shift, right mouse button click, and open PowerShell window here. And now we should simply be able to right mouse button click to copy and also execute this. Alright, verifying that the output frames here, that they are 190 as was previously stated here. If we check here, the number of frames here, 190, very good. And now having these 190 frames properly extracted, we can go back to the Grasshopper definition, and then here if we see the second option of these two, the one that is more suited for this workflow where you create a time-lapse from extracted frames. The main difference is that we force a certain codec, the Apple ProRes, as well as the Apple Audio codec, and by forcing the use of these specific codecs as well as outputting it in the Matroska file container, we will increase the compatibility with DaVinci Resolve. So we can simply right mouse button click here, copy data only, go back to PowerShell, and then right mouse button click. With the pulsating underscore, we can go back to the directory, and here we have our time lapse, very good. And then we open DaVinci Resolve, and here we can create a new project. It is very temporary in nature, so we can keep this until project 3, create. And the first thing we want to do is to go to File and Project Settings, and here we just want to make sure that the timeline frame rate is the one that is closest to our frame rate, ours being 23.837 and 23.976 being a good candidate then for the project frame rates, and save and change. And then we can go back here and click and drag the time-lapse into the media pool here, and then go into edit workspace, and here with the media pool visible we can click and drag this here, and here we have it. We'll go back here and click and drag the audio as well. By pressing N on the keyboard we activate snapping, and thus we can easily snap it to the beginning there. If we hold Alt and scroll, we increase the zoom in level, and here we see that we are a couple or perhaps 3 frames behind, so to say. Now we are actually only 1 frame ahead, but what we can do here is to Alt scroll out again. With the B key create a cut here, with the N key activating the magnetic snapping again. Pressing A to select this, Ctrl Shift X to delete. Going to the front again, wherever the playback head is, we can simply Alt scroll into here. And now we should be able to press T and trim this, and then we can trim it so that it is as well aligned here as possible. And now scrubbing the playback head forward and backward, we see here that the change of frames is a little ahead. And remember that the playhead here shows the frame that is to the right of the playhead. So this is the frame that starts here but ends here. The frame that we see here is the one that is from this position in time to this position in time. And as such, when we see that we go 1 ahead and it changes, it is quite adequately synchronized to the music. And if we select it here, I would say that it's okay, definitely okay. And here it changes there, so then it's definitely okay as well. And if we go further here, one evidently sees that it's a little fluctuating, whether it's right on the spot where it is here, or if we check here, then it's a little before, and in the immediate end here, it is quite significantly before, but as initially stated, we have a tolerance of up to 1 frame, and this is definitely showcasing that. If one would have chosen a higher frame rate for the intermediary footage, perhaps 54.175. A higher frame rate of the intermediary footage might diminish these deviations even more, but for this use case it is quite acceptable. Let us create a simple crossfade here, as well as a shorter one for the video, and we'll do the same for the start, so pressing the home key here, and we'll add a short one there, and we can add a short one here as well. Very good. Now we can enter the delivery workspace, and we can change the format from QuickTime to MP4. And then we can add to render queue 240428 BPM and FPS sync, and enter the save, and then render all. Let's go to the file and let's see how this turns out. Well, to be gentle, far from fascinating, nauseating indeed, but no matter the cinematographical flaws, still a valid showcase for how to, within a certain tolerance, synchronize the frame rate to the pacing of the audio. Thank you for your time.